Center of mass, momentum, impulse, and collisions.
So, what is the center of the mass, momentum, impulse, and collisions?
Momentum. Momentum can be defined as mass in motion. It is commonly used in sports. A team that has the momentum is on the move and is going to take some effort to stop. A team that has a lot of momentum is really on the move and is going to be hard to stop. Momentum is a physics term. It refers to the quantity of motion that an object has. A sports team that is on the move has the momentum. If an object is in motion, then it has momentum. Example: consider a 0.5 kg physics cart loaded with 1.5 kg brick and moving with a speed of 2 meter per second. The total mass of loaded cart is 1 kg and its momentum is 2 kg meter per second. If the cart was instead loaded with 3.5 kg bricks, then the total mass of the loaded cart would be 2 kg and its momentum would be 4 kg meter per second. A doubling of the mass results in a doubling of the momentum. Similarly, if the 2 kg cart had a velocity of 8 meter per second, then the cart would have a momentum of 16 kg meter per second.
Impulse. If you've ever kicked a ball, hit a punching bag, or played sports that involved any kind of ball, you have been using the concept of impulse without even knowing it. So, what exactly is impulse, and what does it have to do with any of those situations? Impulse is the change of momentum of an object when the object is acted upon by force for an interval of time. So, with impulse, you can calculate the change in momentum, or you can use impulse to calculate the average impact force of a collision.
Applications. The most notable example is the car airbag system. Airbags are in the car in order to reduce the damage to a driver or passenger during a collision. If impulse is force multiplied by time, then force is impulse divided by time. What the airbag does is increase the time required to stop the momentum of the passenger or driver. If this time is increased, then the force of impact is decreased. If the impact time is short, then the force of impact increases and may cause severe damage to the occupants of the car.
Center of the mass is a position defined relative to an object or system of objects. It is the average position of all the parts of a system, weighted according to their masses. For simple rigid objects with uniform density, the center of mass is located at the centroid. For example, in the figure 1, center of mass for some simple geometric shapes, the red dots, the center of mass of a uniform disc shape would be at its center. Sometimes the center of mass doesn't fall anywhere on the object. The center of mass of a ring, for example, is located at its center, where there isn't any material.
Collisions. Collisions occur when one object strikes another. Problems involving collisions are usually solved using conservation of momentum and conservation of energy. There are two types of collisions: inelastic collisions, which momentum is conserved, and elastic collisions, which momentum is conserved and kinetic energy is conserved. For example, if the objects collide and momentum and kinetic energy of the objects are conserved, then we call this collision a elastic collision. On the other hand, if the momentum of the object is conserved but kinetic energy is not conserved, then we call this type of collision a inelastic collision. In elastic collisions, some of the kinetic energy is converted to heat and sound. The picture given shows the examples of elastic collision in which both kinetic energy and momentum of the system are conserved. Picture shown, which is an example of an elastic collision, momentum of the objects is conserved. However, kinetic energy of the objects is not conserved. Sum up, we can say that momentum of the system is conserved in both elastic and inelastic collisions. However, kinetic energy is conserved only in the elastic collisions. So that's the end of the discussion about the center of the mass, momentum, impulse, and collisions.